Welcome, everybody. This is the Rotary E-Club of Silicon Valley, and every week we bring you people who are doing all sorts of interesting things that we just want to hear about. Why? Because we love innovative approaches to making the world a better place. And our speakers are often people who are finding really clever ways to do that, whether locally, globally, or digitally. This is the Rotary E-Club of Silicon Valley. We have members strewn across 12 countries. We are an online and asynchronous club, and love that our flexible model allows us to connect with people all over the world. Rotary itself, 1.4 million Rotarians and Rotaractors in 36,000 plus clubs who take an interest in finding ways to make the lives of others better. So today, our speaker is Mihir Pershad, and he is joining us from Singapore. You will learn a little bit about his background in biochemistry and all sorts of innovative business possibilities, but he's going to talk to us about cultivated seafood and cultivated, not caught. And so we are excited to hear about why you are in this line of work, what it is Umami is doing, and why that's a great thing. So Mihir, welcome to the Rotary E-Club of Silicon Valley.
Thank you for having me. I will go ahead and share my screen here. And so thanks again, everyone, for joining. And I'm happy to share a bit about my background and why I got into this business, as well as tell you a little bit more about Umami Meats and what we're working on. So I started as a biochemist in, I think, the way that many biochemists start, working in the alternative protein was not anything in my purview. I was working on muscle cells and how they degenerate in disease and working in a traditional biochemistry lab. And from there, I found that I didn't like lab work pace moved too slow for me, but I really loved the science of it. It's just the pace of working in academia was not well suited to my temperament. So I went and joined a venture studio where I sat on the opposite side of helping find commercial applications to technologies that were being developed at universities. And while I was there, I ended up building a handful of businesses in the seafood space. So I got to learn over 3.5 years, kind of a really quick and dirty deep dive into the seafood business, how we produce fish on farms and where the big challenges are. As you might expect, the challenges are pretty similar to what they are on land, trying to make the feed cheap enough, disease management, and breeding issues because we have a very limited kind of stock to breed animals from. But what I realized was that we were depending on aquaculture or fish farming to produce all of the growth in supply of fish, because wild catch supply had been stagnant since the 80s, and that was actually getting worse now because of climate change and other things like overfishing, depleting stocks. And so I started to recognize that fish farming had some what I thought of as not fatal flaws, but major challenges that would not let it grow fast enough to meet the full demand that was coming. And so I decided to get into this business to start finding another way to make seafood, but in particular for species that can't already be farmed. And I thought this was really important because we wanted to focus on species that people want to eat, but that you can't farm or get in sufficient numbers from wild catch because they're endangered. And so there are catch limitations and practical limitations on how many you can actually access. When we pair that with growing demand, what we basically have is a market that wants to buy products that we can't make at any price. And so our goal is to produce via cultivation or growing cells products that are relatively premium and also high risk of extinction. And we're starting with eel, tuna, and red snapper. But this category is actually much broader than you might think. It includes species like cod, halibut, flounder, etc. There's probably 24 species that kind of fall into our purview of the something like 300 species that people might eat out of the ocean if you go to a country like Japan. And the technology that we use to do this is that we start from a fish and we harvest 2 to 3 grams of tissue. And those 2 to 3 grams of tissue contain stem cells. So we go through a process of isolating those stem cells from the fish. And we isolate a special kind of stem cell. We're the first to do it in fish, and it allows us to produce muscle and fat from the same stem cell, which means we can make all kinds of seafood products that are high fat. Otherwise, you end up with muscle, and then you need some coconut oils or other fats to produce kind of a hybrid blended product, but it won't melt the same in your mouth and it won't feel quite like fish. So our view is that by producing fish muscle and fish fat together and developing kind of a core process to do that from one cell type, we can maximize the efficiency and help bring costs down on producing via this new technology. We then take the mature muscle and fat that we're producing and we put it into more of a traditional food manufacturing process downstream to form fish fillets or value-added products. Could be a battered fish for fish and chips. It could be small portions of like a glazed teriyaki pre-packed fish that you just take out and bake. And so the goal for us is to produce a wide range of products using our tech. And we don't actually want to be a company brand making fish products that you go buy Gordon's fish sticks with Umami's name on them. We actually view ourselves as a production technology company. So we want to empower the whole industry to shift to cultivated production because we don't think we can actually, we can't solve the problem ourselves, even if we wanted to. Global seafood supply is something in the neighborhood of 180 to 200 million tons a year. And right now, companies are talking about building first commercial plants of about 10,000 tons. So there's a pretty big gap between what we think we can produce at a single factory and what we need to produce to meet some kind of global gap in the 50 to 100 million ton range over the next decade to 2 decades. And so our view is that what companies really need is something that's standard and can be automated and is modular, because then we can get that modular technology approved as a novel manufacturing process for food. And anybody in a country can then use that to manufacture the species that we can provide to them. So we can then feed in eel, tuna, red snapper cells that we've developed. And our customers who are working with us on a licensing basis can then put that into the same architecture for manufacturing. And that gives them a lot of versatility. It gives them the ability to follow seasonal trends where people maybe want to eat eel in the summer and they want to eat fatty grouper in the winter, and be able to balance out market trends with production capability, which is something you can't really do out of the ocean. So it's a nice way to actually create incentive for companies to join this technology approach. And the core of our business is basically creating process controls, optimization models, and development know-how around the kind of product formation. And the last piece that we do with this is then we can create kind of a co-label, like a Qualcomm or an Intel or a Gore-Tex, where we can then say powered by or umami inside as a concept. And that helps to consumers to connect the dots and say, all these products that I like are made by this approach. Let me go seek out other products that I may not have been looking for that have this technology producing them. And I mentioned machine learning, and I think this is one of the core areas where we see tremendous potential. Machine learning has come to biotech. I think Ginkgo is kind of the first breakout company to really showcase how machine learning could drive massive value across kind of biotech. But now there's a whole cottage industry forming around industrial biotech. And we're taking this and applying it in a totally new field, which is to growing fish cells, where there's very little data available. So we need some help from computers to make us more efficient. So what we do is we develop experimental plans based on DOE or statistical design experiments. We capture data like what does the fish grow in normally in terms of water temperature, salinity, et cetera? What do we feed them and how do they consume that? What waste products are they producing? How well are they growing? And what do they taste like? And then we take all of that data and basically form kind of a proprietary data structure. We use that to train digital twins. And we have 2 digital twins. One is for the cell that helps us figure out how each individual cell is processing the energy and nutrients we're feeding it. And the second is for the actual bioreactor, for the production reactor, and looking at the process and how we can optimize that. Those 2 pieces together allow us to run simulations of potential experimental designs to then take the top 1/3 roughly of those designs and then that are most likely to succeed and use actually generative design, similar to these generative kind of art models you may have seen. But in our case, we're not generating images. We're generating experimental designs based on successful digital runs. And then we run the experiment again. And what this really does is it takes a tremendous workload burden out of the lab for experiments that are very unlikely to succeed anyway, and helps us to save time and money on the development cycle. And our goal is with time, this accelerates. It lets us reduce costs faster, but it also lets us take learning from eel and apply it to tuna because they're not the same fish by any means, but there's substantial overlap compared to trying to take data from human cells and figure out how to work backwards to fish. And in the long run, we want companies to be able to bring us a product and say, I want a halibut fillet. And we can reverse engineer the experiments to figure out what gets us close to a halibut fillet properties before we actually go run experiments. But one of the key challenges with Cultivated is that right now we're not really sure how people are going to respond to it in the market and how we can convince consumers to acquire these repeat purchasing behaviors for this kind of product. So we ran a study on the market in a couple of Asian countries because we're based in Singapore, and looking at like what would people want to see to make them buy cultivated products and what would give them pause. And the interesting thing was that purely educating people about cultivated seafood, so anybody who came in knowing about the product before being given our survey, was 3 times more likely to try the product, want to try the products. And I think that's a really good sign because it means we don't have to do a ton of education, but we do need to make people aware that the technology exists and let them sort of discover on their own, maybe go do some digging and figure out why it's beneficial. We can obviously sell in seafood the fact that there's no mercury, there's no heavy metal, and there's no microplastics, which means it's safe for pregnant women, it's safe for young kids. But it also means that we're protecting endangered species for the long term so people can continue to eat what they want to eat. You don't want to look back in 30 years and say, wow, it would have been really nice to be able to get a cod, fish, and chips, and I can't do that anymore because we overfish cod. And our focus is really on making food at the end of the day. I've talked a lot about biotech, but the reality is we have to make delicious food that resonates with consumers across the world. And so our way of doing this is by partnering with large food companies and fishing companies that know consumer markets and that have brands that are already well trusted in their market. And so we rely on them for the cultural instinct of what kind of dish are consumers looking for that's currently a gap in the market. How can we build a localized supply and manufacturing chain? Because one of the best ways for us to reduce emissions is to go directly to manufacture outside of Tokyo for Japan, outside of Seoul for Korea, as opposed to manufacturing where the fish are, which is what we do today. And then we ship them all over the place with a very extended cold chain. And then we bring on distribution partners to help us get these to market. And our roadmap is basically to start with fillet chunks. So we're working with red snapper as a species for our whitefish, but to basically develop fillet chunks that could go into soups, noodles, dishes, other kinds of prepared dishes, especially in restaurants. And then to launch a grilled eel for the Asian consumer, closely followed by a smoked variant for Northern Europe. Northern Europe is going to be a little bit more dependent on regulatory timeframes, but we want to bring back the tradition of smoked eel that's basically disappeared because eel catch is now banned in the EU because the species is critically endangered. And then we want to move toward whole fillets and sushi grade that's much more versatile and that chefs can use in any way they can imagine, the way that they would a traditional product. I just want to highlight a couple of the people we've been able to bring into helping us build this because it wouldn't be possible without the team of scientists that you see here. We have 13 people today, mostly based in Singapore, but now starting to expand internationally. Many of our team are stem cell biologists. Dr. Vijay Kumar actually helped build the world's first fish cell bank and spent 20 years of his career, basically his whole career, working on fish cell line development. So we're a leading expert in fish cells, not a big industry. And our director of strategic partnerships has actually spent about 15 years back and forth in North Asia, helping American and European companies get into the Asian markets on JV. And so I think we're kind of building very cognizant of the tech that's required, but also the commercial angle that's needed because good tech needs strong commercial drive to get to market. And often there's a hurdle in that it's expensive to get good tech to market when you're a deep tech company. And so we have to think through not just the science and not bring on just good scientists, but also bring on strong commercial minds about how we get this to the customer at the price point they can actually want to buy it. So thanks very much for your time and look forward to the Q&A.
Fantastic, Mihir. Thank you so much. I'd like to do a quick introduction of our group, and then we will leap straight into questions because I know I have a list, and my guess is Heather does as well. Joining us from Heather, are you in Oregon or Mexico at the moment? Mexico, but part of the Rotary Club of Eugene Metropolitan in Oregon is my program's colleague, Heather Edwards. Heather, always good to see you. My name is Rushton Hurley. I am the program's guy for the Rotary Club of Silicon Valley and its charter president back in the day. And Mihir, man, I was just thinking to myself, it is a joy to hear somebody talk about something complex in a way that is clear and easy to understand, and you win big kudos on that front. So nicely done. Now, first, the name of the company, Umami. I lived in Japan for a couple of years, and I'm curious where the connection may be other than what you've described in terms of this is very much going to be one of our markets.
Yeah. So I think initially I'd love to say that there's a whole story where, I tripped over a fish and the word came into my brain and that was the rest was history. But, for us, the idea was basically, we knew we were a biotech company in a lot of ways, but we wanted a name that would resonate with consumers and make them feel about the food the way that we wanted them to feel when they were eating it. And so we went in search of words that kind of conveyed the essence of what good seafood is. And actually, Ajinomoto, about 100 years ago, coined the term umami and took it global for MSG. But the concept is actually that umami is a flavor that kind of uniquely describes a flavor profile you find in seafood and meat, but it's particularly strong in fish. And so we said that seems like perfect encapsulation. We want people to eat this and say it's umami. And so that was kind of the origin of the name.
Thank you. Heather, I think you've got a question on related to meats.
I have a few. I'll start with that one, if that's all right. Mihir, thank you so much. And thank you so much for what you're doing and the impact that this is going to have. I think one of the things that we talk about in a lot of presentations where people are doing innovative things is that they're giving us hope about the climate crisis and things that we tend to feel hopeless about. So thank you. Thank you for that. My question is parallel to what you're doing. Are there opportunities to do this with meat, not fish?
There are definitely, and there are certainly many more companies working on this in the beef and poultry and pork space compared to in seafood, which I think from a carbon mitigation perspective is necessary. I think the challenges for meat compared to seafood is price point for kind of the products you can get to market, because new technology is always expensive. At the beginning, this is no different. I think we look at a very Tesla-like strategy where you launch into premium, you build the aspirational value, and then take it mainstream. And the aspirational value in most, it's not really a whole lot of that in chicken, and in pork, maybe if you look at like Iberico ham kind of segments, but in seafood, there's entire species that are just high value. And so you can prepare those however the technology kind of demands to get something that is appealing initially. But in beef, you really have to have a thick cut kind of whole steak to be able to sell at that sort of price point. And I think that's going to be a challenge to get something that consumers say, I'm willing to pay this higher price point for from day one. Because otherwise you're left with kind of ground products, which are not really going to carry a premium.
So the strategy is to create a higher end good. And then
initially
entry for the market.
Yeah. And initially to focus on, in our case, species that already have that high price point and to enter at parity with what people are already paying. But those are certainly elevated prices compared to a commodity.
It's more of a transitioning into this market through luxury goods.
Yeah. And I would say, we look at, so like not caviar, but eel is a product that is about $80 a kilo into the B2B channel in Japan. And so consumers are paying for more above $100 a kilogram to eat this, but you're not eating massive amounts of it. You don't eat a 12 ounce eel. You eat small pieces of it. So your price per dish might be $30 to $50. So it's in a mid range to a high end kind of restaurant, but the product itself is very expensive. And so we're not having to tell people buy salmon, but pay 3 times as much for it. Because I think that's a really tough ask.
Thank you. That makes sense. So
when you gave us the slide on your team, I was looking across the different universities represented as well. And it struck me that, and I believe I saw right that University of North Carolina
that's where I'm from. Yeah.
All right. And tell me about the education for being an innovator. So I'm curious whether that was present in what you experienced at UNC, or if that's something that was really a part of your experience following graduating from college. But as someone who's very interested in how to help young people tap into creative ideas and then develop the kind of grit that allows you to see a project, through into something interesting. Where was that for you?
Yeah, I mean, I think some pieces of it definitely come from like my parents. Both my parents are scientists. Oh, my dad's an engineer technically, but sort of seeing, I think learning to see the world through a certain lens where you look at things kind of in a problem solving sort of way. And I think probably I was trained to think about things and look for solutions and go find answers myself. And that inquisitiveness was sort of something that was instilled in me from a pretty young age. I was like a voracious sort of reader to the point that it probably was not great for my eyesight. But, I think the university, so I studied biochemistry, and I think Biochemistry, especially Carolina, is very proud of how well known their graduate programs are in chemistry. And so the expectations, even at the undergrad level for people studying chemistry, are to more developing thinking and less rote memorization of things. And I think that sort of thing really helps when you're trying to come into turning science into a product, because you have to not just memorize reactions that somebody developed and won a Nobel Prize for, but actually think through how you do things differently and how you can eventually make improvements. For me, I started a nonprofit when I was at the university, and that was my first foray into anything that was not science. I was pretty dogmatically pre-med when I came into university, and then realized, I think, that I would be very frustrated again in a system that was that linear, where it was, do this, then take this exam, and then do 2 years of this and take another exam, and then 5 years of that. I said, okay, I think there's probably another way to do this that gives me more creative freedom. And that was the reason I went and joined a venture studio, because I figured no real better way to learn how to do this directly than to go do it over and over again and kind of test whether this fits personality wise. And I think those are great opportunities because you get to build companies in a little bit more of a protected environment. You're not worried about running out of money tomorrow, and can really have more kind of mentorship to learn some of the critical skills to get ready, because biotech companies are hard to build. Founders tend to be older. You see fewer 20-year-olds straight out of university building kind of deep biotech companies. And so I think that experience is invaluable to me in helping me figure out what not to do building this kind of company versus, maybe what you would learn if you're launching a consumer facing software app that you could kind of look very different.
So thinking about the consumer then, I think about a design thinking process that starts with understanding the person that you are trying to build for, sell to, help, teach, whatever, right? And for me, there was a bit of dissonance that you can probably correct. When talking about the value of cultivated seafood, how without the pollutants, you're dealing with something that is healthier. That I think I saw that the raw seafoods become much safer or completely safe to eat based on your processes, things like this. That is a message that would appeal to the consumer of the product. But your company is not creating the products. They are making it possible for other people to create the products, if I understood correctly. So yeah. What for you represents how to appeal to your customer base? Are you essentially talking about the consumer to establish that you're speaking the same language, or is there something a little different about how you want to approach making sales of your processes to companies that will then be selling to their local consumers?
I think it's a bit of both. And I think it's interesting. I would say not a lot of people that I've talked to kind of pick up on the difference there between how do you sell your B2B customer and how do you sell the consumer. But I think in some ways to sell a B2B company, a product to a company, you almost have to especially in a new category, we're kind of category making in some ways. And so we have to help our customer understand how we solve problems for their consumer. Because that is basically how would this fit into something they would manufacture, and how does it solve problems their customers are coming to them with? And so definitely the sustainability angle and the kind of clean, healthy food angle is a big piece of presenting our solution. But I think there's really practical applications here. Running fishing fleets is getting incredibly expensive. Fuel prices went through the roof last year, and the long-term trend has been fuel getting more expensive, and these boats burn incredible amounts of bunker fuel. And now for product quality reasons, they're running separate freezer boats out with the fleets to the deep Pacific, for example, to deep freeze to -40, -60 in the ocean and store fish. And that's also not an energy efficient process, as you might imagine. So they have real price pressures on their existing business. They have real problems now finding fish because the fisheries are so depleted that they're going out with sonar and looking for where the schools of fish are to try to hunt them down. That obviously means spending more money and more time at sea to harvest less product. And so we make a very financial case to them. We say the ESG angle is very nice to have, but realistically, people make decisions on how it impacts their bottom line. And we can be cynical about that, or we can say that that's how people make decisions, and let's appeal to that. And we can say we can build a factory rather than buying a couple of boats. This factory gives you seasonal flexibility. It gives you the ability to more directly appeal to what your consumer wants. And it gives you security. You're not having to say, well, I go out and maybe I catch 30% less fish and the whole voyage is unprofitable for me. And so I think being able to say consistency, profitability, and security of supply chain are major things that appeal to our customer directly. And ability to still control the brand, I think, is critical as well, because these companies have built 100-year, 200-year reputations as purveyors of quality seafood. And they want to maintain that even if they go into a new mode of making that fish.
That fascinates me on so many fronts. The idea that you are using the story that they need to engage them in the discussion that they then can have, which is actually the one that they need to know, is, I mean that's really, really interesting, right? And so you had a slide about the willingness to try these things. I wasn't surprised. I lived in Japan for 2 years. I wasn't surprised to see the number quite far down for Japan. But of course, that kind of number represents once it's tried, right? Just, the decision is completely different. And so when thinking about the stories that have to be told to consumers, is that something that you then engage in as part of a process? So, and the way I frame that is that, there are commercials about Intel Inside, right? Like, you've got the right chip in your computer but that's Intel. That's Intel setting something out there for consumers, but mostly for their B2B partners. Same approach for you guys then? I mean, do you anticipate that kind of public relations will be a part of your work?
Yeah. So I think there is, and Intel's taken a little bit of a different approach than I think most people did. I mean, they went in and they said, we're going to spend $100 million a year on marketing ourselves. I think a lot of times companies that do this sort of co-branding approach will have part of their commercial agreements include cash from the partner to be allocated toward marketing and branding that includes the co-brand. We haven't figured out exactly what that strategy looks like yet, but I think there's sort of the macro approach, which is we need to have multiple touch points that build confidence with the consumer and that show them that, number one, biotech's everywhere in food. It's been in yogurt for years and years. It's been in cheese for decades. It's one of these things that people eat every day without thinking about it. And we need to position Cultivated, I think, in a similar way. But then there's the smaller picture of how do you make somebody make a decision when they're exposed to the product for the first time in a setting where they can actually acquire, whether it's a retail channel or a restaurant. And I think that approach is much more working with chefs, working with restaurants, especially in seafood. Chefs are the biggest advocates for what goes on their menus, what consumers should be eating, what they shouldn't be eating. And they should be, right? I mean, they're the guys who cook it every day. And so they know what the constraints are. And more even than the managers of the restaurants or the hotel chains where they work, they're the ones who I think consumers trust if they say, eat this versus that. And I think smart seafood consumer, if they're going to a restaurant, will ask, what's fresh? What came in today? And it's the chef who's cooking based on that. And I think that same behavior is already there. So we can just kind of leverage that as opposed to having to create a whole new way of first convincing consumers to trust the voice and then trust the message. Work with a trusted voice already and save yourself a step.
Mihir, you've given us a masterclass in knowing your audience. Wonderful, wonderful, wonderful. I will wind things down and then hand it back to you for the final word, as we always do. And to all of you who may be watching this recording, thank you for joining us. If you are a member of the Rotary E-Club of Silicon Valley, remember, we would love to have you participate in these recordings because not only do we get the chance to meet these folks, but after we finish recording, we keep talking to them, which is all the more fun for us. There are things that we ask you to do, whether you are a member or a Rotarian or somebody who just happened to show up. And that is to let us know you were here. Just a little farther down our meeting page, you'll see an attendance form and just let us know. Rotarians, if you fill that out properly, you'll get an email that passes that along, that you can pass along to your club secretary if you're making a misses in your club. There is also the discuss forum, and we welcome your giving comments about the different things that we include in these programs, as well as the different elements of the meeting itself. If you are watching us on our YouTube channel, then you can follow links that are below to learn more about the work of our speakers, in this case, Umami Meats, or about our club, which you can find at rotary.cool. Really. So with that, I'd like to hand it back to our speaker for the final word. Mihir, the mic is yours.
Sure. Thanks a lot for inviting me, and thanks everyone for your time. If you've watched this conversation, if you'd like to learn more about us, you can visit us at umamimeats.com, or you can find us on LinkedIn and keep up with all of our latest activities that are going on.
Wonderful. Mihir, thank you again. And everyone, we will see you next week.